So welcome dear students. So today we will be solving some of the important problem related to your worksheet 1, specifically the numerical. Some of the case we will study the conceptual problem also. So make a heading worksheet 1. Worksheet 1 we will write down worksheet 1 will write down page number 2, that is Henry's law. The name of the topic is Henry's law. Henry's law. If you focus on question number 4, question number 4 tells you Henry's law constant for solution given at 298 Kelvin is 4.27 10 to the power 5. Calculate the solubility of that gas in benzene under 760 millimeter of mercury. So they want to know solubility, and from that equation of Henry's law, solubility means always remember X. Solubility means always remember X. So from Henry's law we know that, write down from Henry's law, P equals to Kh into X. Now what are the given thing? Given thing is the Henry law constant given, that is 4.27 into 10 to the power 5 millimeter of mercury. It is given. Another thing given is solubility of methane. Calculate the solubility. Pressure given, that is 760 millimeter of mercury. So you can see both Kh and pressure are of same unit, millimeter of mercury. So you can simply write down P equals to Kh into X from the Henry's law. So X will be P by Kh. P is given 760 and Kh is 4.27 into 10 to the power 5. Just simply calculate, you will get the X value. Okay? Calculation will do it in your home. Achha. Next, question number 6. Question number 6 tells you H2S is a toxic gas with a rotten-like smell, is used for the qualitative analysis. If the solubility of H2S in water at STP is 0.195 molar, calculate the Henry's law constant. So, you will calculate here, okay? Now the thing is that already it is given the solubility, that means molality is given 0.195 molar. And what is the definition of molality? You all know that. That is number of moles of solute. So here solute is H2S, so you will write down number of moles of H2S divided by mass of solvent in kg. So 0.195 molar, it is given the solubility or concentration. The formula of molality is number of moles of H2S divided by mass of solvent. Now in your question it is written H2S in water. So what will be the solvent here? Water. So simply write down mass of water. Now number of moles of H2S divided by mass of water in kg. Suppose if you consider mass of water, is 1 kg. Why you consider mass of water in 1 kg? Because the definition of molality is number of moles per 1 kg of solvent. That means in your definition you are considering the mass of solvent in 1 kg. So that you need to consider mass of water is 1 kg. So if it is mass of water is 1 kg, that means that 1 and 0.195 will be multiplied. So from there number of moles of H2S is coming out to be same. That is 0.195 moles. Again I am saying 0.195 molar, that can be written as number of moles of H2S divided by mass of the water. Now mass of the water you are considering 1 kg, so number of moles of H2S now becomes 0.195 molar. The moles, that is you are getting this part. After that they are saying calculate the Henry law constant. To calculate the Henry law constant, you know the equation P equals to Kh into X. Pressure you already know. Pressure is already known. Why? Because they are saying STP. So at STP you all know that pressure should be key 1 atmosphere. At STP pressure is 1 atmosphere. That means they are indirectly giving you the pressure. So pressure is given. X you need to calculate. Number of moles you have already calculated, but X you need to calculate so that you will be able to get the kh value. So how to get the kh value? It is very important question. How to calculate the X value? Now number of moles of H2S you have got. So mole fraction of H2S, how you are getting it? To get the mole fraction from the definition, you know that number of moles of H2S, that means number of moles of H2S plus number of moles of H2O. Because you all know that mole fraction formula is number of moles divided by total number of moles. So number of moles of H2S you need to know, divided by total number of moles means H2S and H2O number of moles. Now number of moles of H2S you have already got, that is 0.195, but number of moles of water you don't have any idea. So first of all, number of moles of water you need to calculate. Acha, number of moles of water means number of moles formula is weight by mass. Now what is the weight you have taken? Mass of water is 1 kg, so that should be 1000 gram, yes or no? 1 kg means 1000 gram. And what is the molar mass of water? You all know that molar mass of water is 18 gram per mole. So 1000 by 18 means this value is coming out to be near about 55.5 moles. 1000 by 18, always remember this value will be 55.55. So number of moles of water you need to calculate. Number of moles of water can be calculated by weight by molar mass. Weight is 1000 gram because you have taken mass of water as 1 kg. So 1000 by 18 means that value is 55.55. Now if you put this value over here, number of moles of H2S is 0.195 and number of moles of H2S is 0.195 plus number of moles of water is 55.54. By that way you can easily get the X of H2S. Whatever the value coming out over here, this value you will put over here, X. Partial pressure, pressure is already given 1 atmosphere at STP. You will get the kh value. Any doubt? Again I am saying, from that equation you will get the X. You will put the values of X over here. Pressure to 1 atmosphere you will put, kh you will get. Any doubt? Achha. What is the effect of temperature? Question number 2. What is the effect of temperature? What is the effect of temperature? Henry's law. What is the effect of temperature on solubility of gases in liquid? What is the effect of temperature? We all know that the concept ki aquatic animals always feels more comfortable in cold water than the hot water. So you all know that solubility is inversely related to temperature. That means we are thinking about solubility of dissolved oxygen or any dissolved gas. The solubility is inversely related to temperature, so that aquatic animals feel more comfortable in cold water, because in cold water as the temperature is low, the solubility of gas will be high because solubility temperature inversely related. So in cold water temperature low, solubility high. In hot water temperature high, solubility is low. So aquatic animals will get more dissolved oxygen from the cold water rather than hot water. So write down solubility of dissolved gas. Solubility of dissolved gas. Solubility of dissolved gas is inversely related. Right, first step. Solubility of dissolved gas is inversely related to temperature. Full stop. With the increase of temperature, solubility of gases in liquid. With the increase in temperature, solubility of gases in liquid decreases. With the increase in temperature, solubility of gases in liquid decreases. Full stop. So aquatic animals feel more comfortable So aquatic animals feel more comfortable. So aquatic animals feel more comfortable. So aquatic animals feel more comfortable in cold water than hot water. You get my point? Okay. Next we can say question number 3. You can see gas A is more solubility is already done in your class. So question number 3 if you follow. Question number 3 if you follow. Two gases are given. Question number 3 if you follow, two gases are given. Gas A is more soluble than gas B in same temperature. So here solubility they have given. They want to know in which gas they have more K value, more KH value, Henry law constant. So you all know that solubility and KH is inversely related, like temperature. Solubility and KH is inversely related. If anyone asks you why, because solubility is expressed in terms of X, and from the Henry law, you know that P equals to KH into X. Now X can be written as P by KH. You can see X can be written as P by KH. That means solubility is inversely related to KH. You can see. Just see here from the Henry's law, P equals to KH into X. So X you can write down P by KH. That means solubility, that is X, that is inversely related to KH. So I have written solubility is inversely related to KH. So the gas which has more solubility, that means it has lower KH. The solubility which has lower solubility, the gas which has lower solubility will have higher KH. So first of all, write down this relation. Write down this relation. Next, write down here gas A is more soluble in water than gas B. Gas A is more soluble in water than gas B at same temperature. So KH value of gas B. So KH value of gas B. So KH value of gas B is higher than KH value of gas A. So KH value of gas B is higher than KH value of gas A. Okay? Very easy, you can see. Question number 9 already done. Aquatic animals are more comfortable in cold water than in hot water. Feeling of weakness and discomfort in breathing at high altitude, that is the application of Henry's law, we have done it. Soda water bottle kept at room temperature seizes on opening because of the higher solubility of carbon dioxide. That are the applications of Henry's law, we have done it. So question number 9 already done. Question number 10, they are saying the statement of Henry's law, already done. Now focusing on Raoult's law. Now we are focusing on Raoult's law. So see the Raoult's law, very important. Raoult's law, they are saying, state Raoult's law statement already done. It is a special case of Henry's law. All these questions you can see in your copy already written. Acha. What is the similar question number 3 if you follow? What is the similarity between Raoult's law and Henry's law? That is basically the alternative question of Raoult's law is a special case of Henry's law. So the similarity will say question number 3. According to Raoult's law, you know that P varies as X, and according to Henry's law also, P varies as X. In both the cases, you can see partial pressure is directly proportional to the mole fraction. So in case of Raoult's law, partial pressure is directly proportional to mole fraction. In case of Henry's law, also partial pressure is directly proportional to mole fraction. So this is the similarity. So if you just simply equate it, that is pH equal to, in case of Raoult's law, that is P equals to P naught X, and in case of Henry's law, that will become P equals to KH into X, nothing else. So that is basically the similarity. So write down the similarity. So in both this law, state that partial pressure is directly proportional to mole fraction. Partial pressure is directly proportional to the mole fraction. Okay. According to Raoult's law, P varies as X according to Henry's law also P varies as X. Write down. Then the same, define an ideal solution. It is already done. Ideal solutions are those solutions which follow Raoult's law, and write one of its characteristics. So ideal solution, you all know that. So the solution which follows the Raoult's law. Raoult's law means, you all know that. Okay, suppose you have a solute. Question number 4, I guess. Yes. So Raoult's law, that means for ideal solution, characteristic is Pa equals to Pa0x. And if you have B solute, then in that case Pb equals to Pb0x. That means the expected pressure is equal to the calculated pressure. In that case particularly Raoult's law is followed up, and it is one of the characteristic of ideal solution. Another characteristic of ideal solution is that delta mix V, that is equal to 0, and delta mix H, that is also equals to 0. Not only that, another characteristic you know, the mu AB, that will be equal to mu A or mu BB. That means the AB interaction will be equal to A interaction or BB interaction. So these are all the characteristics of the ideal solution. If anyone asks you what is ideal solution, you will write down it follows the Raoult's law. Not only that, you will say the characteristics of the Raoult's law are PA, that means the expected vapor pressure, that will be equal to the calculated vapor pressure Pa0x, Pb, Pb0xb. Second point you will write down delta mix of V, that means the volume after mixing will be equal to 0, and enthalpy mixing also calculated to be 0. Third point you will write down the AB interaction will be equal to A or BB interaction. These are the characteristics of the ideal solution. Then they have said write two difference between ideal and non-ideal solution. You can easily write down. Acha. 6.1, what is meant by positive and negative deviation? We have discussed it. How is the sign of delta H mix related to positive and negative deviation from the Raoult's law? So it is very easy. Question number 6.1. So in case of positive deviation always remember that delta mix H, that is coming out to be positive. And in case of negative deviation, positive means greater than 0, always remember. And negative deviation means delta mix H, that is less than 0, that means negative. Achha. Which type of deviation will be shown by the solution gamma AB less than gamma AA? Gamma means that is mu. This question number 6.2. Question number 6.2, they are saying mu AB is less than mu AA. That means we are saying mu AB means AB interaction is weaker than AA interaction. This suggests to AB interaction is weaker than A. And third, we are asking mu AB greater than mu A. So you can see AB interaction less than sign means it is saying weaker, and greater than sign means they are saying this is stronger. So can you tell me for the weaker interaction what will be your answer, and for stronger interaction what will be your answer? There are two types of deviation. One is positive, another is negative deviation. So in terms of positive deviation, in terms of negative deviation, you need to answer. So here you can see weaker. Weaker means we are following positive deviation. Yes. And stronger means we are saying negative deviation. Remember this. Again the same thing. Write two difference between a solution showing positive and negative deviation. Raoult's law. Increase in temperature observed in mixing chloroform and acetone. Question number 9, if you follow. Why is an increase in temperature observed on mixing for the chloroform and acetone? So that is already discussed. In case of chloroform and acetone, after mixing there is a hydrogen bonding, you all know that. So that sort of answer you need to write down. Question number 9. So chloroform, you need to write down the structure of chloroform like this, and acetone you need to write down the structure like this. So if you see after mixing, here there is a interaction going to take place like this, and this interaction is basically known as hydrogen bonding. So when there is a greater hydrogen bonding, there is a greater extent of interaction, and you require greater temperature to break down the interaction and then to boil it. So temperature increases. So write down question number 9. In case of chloroform and acetone, in case of chloroform and acetone mixture, there is a hydrogen bonding, there is a hydrogen bonding in between, there is a hydrogen bonding in between hydrogen of chloroform, hydrogen in chloroform, and carbonyl oxygen of acetone, and carbonyl oxygen of acetone. Full stop. This leads to negative deviation. This leads to negative deviation. This leads to negative deviation and requires, this leads to negative deviation and requires greater temperature, and requires greater temperature. This leads to negative deviation and requires greater temperature to break down their interaction. Okay. Now question number 10, azeotrope, it is already done. With respect to azeotrope, there is a question in question number 10. What type of azeotrope is formed by negative deviation? Always remember, positive deviation that will generate minimum boiling azeotrope, and negative deviation that will generate maximum boiling azeotrope. So this sort of azeotrope you need to know. Just remember this thing. Question number 10. Question number 10, the alternative question that is given. You always remember maximum boiling azeotrope. Maximum boiling azeotrope. Maximum boiling azeotrope is basically shown by negative deviation. And in case of minimum boiling azeotrope by positive deviation. Always remember, maximum boiling azeotrope by negative deviation and minimum boiling by positive deviation. So they are asking negative deviation. So negative deviation means key maximum boiling azeotrope. What type of azeotrope? Maximum boiling azeotrope. Give an example. So give an example means you can give any example consisting of negative deviation. Like chloroform acetone we have already discussed. So you can give. Question number 11. What type of deviation is shown by mixture of ethanol and acetone? What type of deviation is shown by ethanol and acetone? Ethanol and acetone again they will show negative deviation. And what type of azeotrope negative deviation is maximum boiling? Question number 12. Again chloroform acetone. So they again show the negative deviation, and why there is an increase in vapor pressure. Decrease in vapor pressure observed on the mixing of chloroform and acetone. So question number 11. Question number 11, that is negative deviation, and question number 12, that is the maximum boiling azeotrope. Maximum boiling azeotrope. Question number 12, they are saying what type of deviation? Again the negative deviation, chloroform acetone. And question number 12, they are saying why is a decrease of vapor pressure observed on mixing of chloroform acetone? You already know that, because when there is a negative deviation, PA always less than key, PA0x, and PB less than PB0x. In case of negative deviation, you all know that this observed value and calculated value, these are different, and it is less than that. In case of positive deviation, that is greater than that. So because of that reason, you can see when there is a mixing, there is a hydrogen bonding. What is the reason? You will say that due to the hydrogen bonding, they become associated. When they become associated, vapor pressure decreases. So write down. Question number 12(2). In case of mixture of chloroform and acetone, in case of mixture chloroform and acetone, in case of the mixture chloroform and acetone, the mixture gets associated due to hydrogen bonding. The mixture gets associated due to hydrogen bonding. The mixture gets associated due to hydrogen bonding. Full stop. As a consequence, vapor pressure of the mixture vapor pressure of the mixture decreases after mixing. Question number 13, page number 4, you can see. Question number 13. In non-ideal solution, what type of deviation shows the formation of maximum boiling? See, the similar type of problem asked. Maximum boiling aziotroph they are saying. As I have already said, maximum boiling aziotroph means key. What type of deviation? Negative deviation. Maximum means key negative. Maximum means key negative. And minimum means key positive. So maximum negative. Okay. Write two characteristic of non-ideal solution. You can simply write down. In case of non-ideal solution, PA greater, first of all you will write down not equal to PA0 XA, PB not equal to PB0 XA. This is the first. Second option you will write down delta mix of volume not equal to 0, delta mix of H not equal to 0, that is the property of the non-ideal solution. And third you will write down mu of AB not equal to mu of A not equal to mu of B. That means AB interaction is not equal to A interaction or BB interaction. Okay. Next question number 17.1. 17.1 they are saying on mixing liquid X and Y, volume of the resulting solution decreases. That means delta mixing of V less than 0. So when volume decreases, that means it is an example of negative deviation. So what type of deviation from the Raoult's law is some negative deviation? What change of temperature would you observe? So you can see, it's very important thing. Question number 17. So question number 17.1 write down. On mixing liquid X and Y, on mixing liquid X and Y, on mixing liquid X and Y, volume of the resulting solution decreases. Volume of the resulting solution decreases. Volume of the resulting solution decreases, suggesting the negative deviation. So try to go through the statement carefully. In your worksheet, I have given volume of the resulting solution decreases. Sometimes it may be asked volume of the resulting solution increases. So in that case, we will write down positive deviation. So as it is written decreases, so we have written negative deviation. So try to go through. Sometimes, on mixing liquid X and Y, it is done in the class. So volume in X and Y, the answer should be negative deviation. We write down directly negative deviation without going through it. So try to go through the last point, that is the volume of the resulting solution decreases means negative. If it is written increases, that is positive. Remember this. Next, what change in temperature would you observe after mixing X and Y? That means, just try to understand. As you are saying it is negative deviation, so second thing, delta mix of heat, that should be key, less than 0. Less than 0 means that should be negative. Negative means anything delta is negative. You have already gone through in your class 11. If it is negative, then means the process is key, exothermic. Exothermic means key, temperature will increase. So write down. What change in temperature? Write down temperature will increase after mixing liquid X and Y. Temperature will increase after mixing X and Y. Clear? Clear? So if it is positive deviation, then that should be greater than 0. If value should be positive, positive means key, endothermic. That means temperature will decrease at that case. Clear? Chalo. Write down question number 21. Twenty-one is very important question. It is already there in your NCERT, but it's very important. Remember this. There are two phases. One is the liquid phase, another is the vapor phase. First of all, the vapor phase, The vapor pressure of the pure liquid A and B is given 450 and 700. Find out the composition of the liquid mixture. Same type of question is asked in your recent JEE Mains exam. So you can see very important question related to vapor pressure. Vapor pressure of pure liquid given, that pure liquid means P naught. Find out the composition of the liquid mixture. Always remember, anything composition, that means mole fraction we are asking. Anything composition, that means we are asking mole fraction. Okay. So we are asking the composition of the liquid mixture, that means X we are asking. Total pressure given. Find the composition of the vapor phase. Vapor phase means we are thinking about Y. As I have already said, liquid composition mole fraction is X and vapor composition mole fraction is Y. So both X and Y you need to calculate. Total vapor pressure given, pure liquid vapor pressure also given. So how to do that sort of problem? Question number 21. So question number 21, the vapor pressure of the pure liquid A and B, that means PA0 given, PV0 given. PA0 given koto? PA0 given 450 millimeter of mercury and PV0 is 700 millimeter of mercury. And also in the very second line it is given total vapor pressure PT, that is 600. Now you all know that relation total vapor pressure is equals to PA0 XA plus PV0 XB, that is the relation. Now total is basically 60, it is 600 already given, PA0 given 450 into XA and PV0 given 700. Now XB you can write down 1 minus XA because you all know that XA plus XB equals to key 1. Yes or no? Now 600 you can write down 450 XA plus 700 minus 700 XA. Now you can see it is coming out to be 700 plus 450 minus 700 means 250, so minus 250 XA. Now 250 XA is coming out to be 700 minus 600, so that is 100. Yes or no, please tell me. Now XA should be key 100 by 250. 100 by 250 means that value is 0.4. So when XA is 0.4, XB should be key 1 minus XA. So that is 1 minus 0.4. So that value is 0.6. Okay. So XA and XB you can simply calculate from this equation. Okay. Now the thing is that after getting XA and XB you need to calculate PA and PV. After that you need to calculate, I'll show you, PA and PV. So here PA equals to, you know that PA0 XA. So PA0 is already given in your question, that is 450 and XA is given 0.4, so that value is 180 and PV is equals to PV0 XB. PV0 value is given in your question, that is 700 and XB value you have found, that is 0.6, so that is 420. So again the total pressure you need to calculate, that is PA plus PV in case of vapor phase. Whatever the calculation you are doing, that is for the vapor phase here. So that is 180 plus 420. Again it is coming out to be 600. You can see. Okay. Again it is coming out 600. Now YA equals to, you know that PA by P total. PA though you have already got 180 by P total is 600. So that is 0.3. Now YB, PB by P total, that is 420 by 600, that is 0.7. Or we can calculate YB like this, that is 1 minus YA, that is also 0.7. You can calculate YB by two ways, like PA by PT, PB by PT, or YB equals to 1 minus YA, that will all the time will give you 0.7. So this is a liquid phase calculation, this is a vapor phase calculation. Okay? The value might change, but the concept will remain the same. Question number 22, you will do it by yourself. Question number 22 and 26, similar type of problem. 22 and 26, do it by yourself. Question number 22, just I will tell you what to do. But it is done, do it. I think this part is done. So question number 22. Achha, they have said one is A, another is B. In case of A, they have said weight is 100 gram. Molar mass they have provided 140 gram. So from there you can easily get N. N means ki, N means weight by mass. Weight is 100 by 140. Similarly, in case of B, weight is given 1000 gram, but mass is given here 180 gram. So this is WAMA and this is WBMB. So here you can calculate NB, that is WB by MB. 1000 by 18. This should be gram per mole. Should be gram per mole. So Na and Nb you can easily calculate over here. Now after calculation of Na and Nb, as we have the requirement of XA and XB, so you need to calculate the XA and XB. So XA, what will be the XA? Na by Na plus Nb. That means Na already given, Nb already given. So if you put this value, you will get XA. Similarly, after getting XA, XB should be key. 1 minus XA will do it. You will get the value of XB. Now they are saying the vapor pressure of the pure liquid B. That means PV0 given. See, PV0 given. What is the PV0 value? 500. 500 torr it is given. They are asking calculate the vapor pressure of pure liquid A. That means they are asking what should be PA0. And total vapor pressure of the solution is also given PT 475. So you all know that PT is equals to key PA0XA plus PV0XB. Yes or no? Now PT is already given 475 and PA0 is, you need to calculate XA. XA so you will get here. So you will put the value over here. And PV0 value already given 500 and XB you can write down again 1 minus XA. So after getting XA, if you put this XB already you know the value, so again XB value you can put it over here or you can write it down in terms of 1 minus XA. So you can see XA value in both the cases is known. So from there you will get the value PA0. So from there you can easily get the value of PA0. So similar type of problem you will find in question number 26. The next write down colligative property. So definition you will do it by yourself. We have done it. All the things are done. Colligative property, relative lowering, molar elevation constant, depression constant, osmotic pressure, reverse osmosis, isotonic, abnormal molar mass, Van't Hoff factor, all already done. Give reasons of the following. Acha, it is very important. Question number 2A. Please concentrate. Question number 2A. Colligative properties. Question number 2A. When mercuric iodide is added to an aqueous solution of Ki, the freezing point is raised. What is the reason behind it? Mercuric iodide means HgI2, and when it is mixed with Ki, they are saying mercuric iodide when added to the solution of Ki. it will form K2HgI4. Remember, K2HgI4. This is a complex, and that is 2Ki. So this reaction going to take place when mercury iodide reacts with Ki. There is a generation of K2HgI4. Now mercury iodide when reacts with potassium iodide, they will generate a K2HgI4. This is a complex. This is a complex. Now try to understand in this problem, HgI2 which is present over here and Ki, 2Ki is present over here. So before the reaction, how many molecules are there? 3. But after the reaction, how many complex? Only 1. So number of solute increases or decreases? Decreases. So as the number of molecules decreases, you can see, you all know that I have said colligative property directly proportional to the number of solutes. And accordingly, there is a, you know that lowering of vapor pressure, that means vapor pressure decreases. Boiling point increases because you are saying elevation of boiling point, and freezing point decreases. So when you are going to increase the number of solute, colligative property increases, vapor pressure decreases, boiling point increases, and freezing point decreases because depression of freezing point is a colligative property. But here you can see number of solute decreases. That means the reverse phenomenon will take place. So number of solute decreases means from 3 to 1 number of solute decreases. That means when number of solute decreases, colligative property also decreases. Vapor pressure increases, boiling point decreases, and freezing point increases. So freezing point will rise. So you have seen it is written freezing point is raised. See, it is written freezing point is raised. So write down the reaction and then write down. Have I written the reaction? Write down the reaction. And this complex is used in one of the very famous identifications of a particular basic radical. That is, it is also called Nessler reaction, and it is used to identify the ammonium ion. So from there, the question is asked. Write down. After writing this reaction, write down. In the above reaction, number of solute decreases. In the above reaction, number of solute decreases. In the above reaction, number of solute decreases. In above reaction, number of solute decreases. As a consequence, colligative property also decreases. As a consequence, colligative property also decreases. Full stop. Depression of freezing point is a colligative property. Depression of freezing point is a colligative property, which depends on the number of solutes. Depression of freezing point is a colligative property which depends on the number of solutes. Full stop. So, with the decrease in number of solutes, freezing point will be raised. Freezing point is raised. To be, so you can simply write down the cooking is faster in pressure cooker than in cooking pan, because in cooking pan there is no partial pressure generated, but in case of pressure cooker there is a partial pressure, extra pressure is applied so that boiling point is easily reached. So there will be elevation of boiling point. So as a consequence, cooking is faster. You can simply write it, it's very easy. Next, red blood cell shrinks in the saline water. It is due to the osmosis, we have done it. Sodium chloride solution freezes at lower temperature than water. It is very important. Sodium chloride is an electrolyte, so it will dissociate to give you number of ions, more number of ions. So when sodium chloride will give you more number of ions, number of solute increases. With the increase of number of solute, colligative property also increases. So when colligative property increases, that means freezing point decreases. So that you are saying कि sodium chloride solution freezes at lower temperature. So write down very easy. 2D write down. First of all write down NaCl arrow Na plus plus Cl minus. 2D write down NaCl arrow Na plus plus Cl minus. Then write down NaCl is an electrolyte. NaCl is an electrolyte. So after dissociation, number of solute increases. So after the dissociation, number of solute increases. So after the dissociation, number of solute increases. Full stop. Depression of freezing point is a colligative property which depends on the number of solute. Depression of freezing point is a colligative property which depends on the number of solute. So here colligative property. So here freezing point decreases. So here freezing point decreases due to increase of number of ions. Question number 2, it is said a person suffering from high blood pressure is advised to take minimum amount of salt. Same reason. If you take more number of salt, maximum amount of salt, that means salts to are electrolyte. That will dissociate to give you ions. Number of solute increases. So colligative property increases. And colligative property increases means it is directly proportional to the osmotic pressure. So osmotic pressure of blood also increases. So person suffering from blood pressure already have high osmotic pressure, and you are giving maximum amount of salt. That means also increases the osmotic pressure, because salt is an electrolyte. It will give more number of ion. More number of ion means more number of solute. That means colligative property increases. That means osmotic pressure also increases. So that will create problem. Because of that reason, it is said to take minimum amount of salt. 2F already done. At higher altitude, people suffer from disease called anoxia. Application of Henry's law. 3A. Why does sprinkling of salt helps in clearing the snow covered areas in hilly areas? So basically, salts are electrolyte. Electrolyte means it will dissociate to give you ions. That means number of solute increases. When there is an increase of number of solute, freezing point decreases. You can see freezing point decreases. So when freezing point decreases, that means you can easily clear the corresponding ice, which is basically covered in the hilly areas. Because in the hilly areas there is a problem with the traffic. There is, you can see there is ice gathering in the corresponding road. So it is very much problematic situation. So we will sprinkle some amount of salts into it, so that with the increase of the salt, there is a number of solute increases. And when there is a number of solute increases, that means colligative property increases. Colligative property increases means freezing point decreases. That means it will be easily converted into water. Okay, so write down 3A. As salt is an electrolyte, comma, it dissociates to gives more number of ions. It dissociates to give more number of ions. So colligative property increases. It dissociates to give more number of ions. So colligative property increases. That is, freezing point decreases. So sprinkling of salt. So sprinkling of salt helps in clearing snow-covered roads. (3B) it is asked, if you have choice between NaCl and calcium nitrate, which salt will you prefer? So NaCl will dissociate to give you Na plus and Cl minus, only two ions. But calcium nitrate, in place of calcium nitrate, we may provide you calcium chloride also. So calcium nitrate will give you one calcium 2 plus and 2 nitrate. That means 3 ions. So after the dissociation, calcium nitrate will give you 3 ions, sodium chloride will give you 2 ions. So remember, with the increase of the number of solute, colligative property increases, so freezing point will decrease more. So they are asking which salt you will prefer. That means the salt which you will prefer having more number of solute. So calcium nitrate will be the answer. So write down. First of all, write down NaCl arrow Na plus plus Cl minus. NaCl arrow Na plus plus Cl minus. The next line write down CaNO3 whole twice. CaNO3 whole twice arrow. Ca2 plus plus 2NO3 minus. Ca2 plus plus 2NO3 minus. Okay. So when you have the line where you have written Na plus plus Cl minus, within bracket write down 2 ions. And where you have written calcium nitrate Ca2 plus 2NO2 minus, where within bracket write down 3 ions. 1 calcium and 2 nitrate. Okay. So write down next line. With the increase of number of solute or ions, freezing point decreases more. So calcium nitrate is preferred over NaCl. CaNO3 whole twice is preferred over NaCl. Now relative lowering of vapor pressure, make a heading relative lowering of vapor pressure. Relative lowering of vapor pressure. Question number 2, so very easy. Question number 2, they are saying vapor pressure of the water, that is the pure solvent, it is given 17.55. Calculate the vapor pressure of water when 25 gram of solid is added in 450 grams. So we know that the formula, we know that P0 minus P by P0, that is X2. X2 can be written as N2 by N1 plus N2. Now N2 further can be written as W2 by M2 divided by W1 by M1 plus W2 by M2. Now in your question it is given P0 given 17.535. They want to know the P. So P0 is 17.535 minus P by again 17.535. That is coming out to be W2 by M2. What is W2 given? W2 is the, always remember, 1 means solvent and 2 means solute. So W2, that is the weight of the solute. How much amount of glucose? 25. And M2, you need to know the formula of glucose in order to calculate the molar mass. Glucose is C6H12, C6H12O6. C6H12O6 is glucose. So the mass is 72 plus 12 plus 96. What is the value? 180. So 25 by 180 divided by W1, that is the weight of the solvent. Weight of the solvent given 450 gram. 450 by mass of the solvent is 18 plus again 225 by 180. So if you calculate, you can easily get the P. So do it by yourself. What is P? You will do it in your home and also calculate it. Okay. It's not like that you will just simply do it like up to this one and it is done. This sort of calculation you need to do it. Question number 3, similar type of problem. 4 also. Question number 5, very important. Question number 5, they are saying at 25 degrees Celsius saturated vapor pressure of water is given. Find the saturated vapor pressure of the solution. Same problem. P0 minus P by P0, that is equation you will write down W2 by M2 divided by W1 by M1 plus W2 by M2. Okay. Now in your question it is given, question number 5, in question it is given vapor pressure of the water given, that is 3.165 kilopascal. You can also use the millimeter of mercury, they have said 23.75, so you write down 23.75 minus P by 23.75 Now W2, what is the W2? W2 means the mass of the solute, you can say. Now it is given 5% aqueous solution of urea. From that you need to calculate 5% aqueous. It is very important. 5% aqueous solution of, they are saying, urea. That means this is weight by weight percentage, and in my concentration terms weight by weight percentage calculation I have said anything percent given you can represent it by weight. That means 5% aqueous solution of urea, that means urea is 5 gram and water is key. Aqueous solution is water is key 100 gram. Sorry, solution is key 100 gram. If solution is 100 gram, then water is 100 minus 5, that means key 95 gram. That sort of question we have done it 10% sucrose solution. So 5% aqueous solution of urea means urea is 5 gram and it is present, that is the weight in the denominator, means key solution is 100 gram. So water is solution minus urea, because solution means key solute plus solvent. So solute is 5 gram, so solvent should be 100 minus 5, 95. So this is urea, that means that will be W2, and this is water, that should be W1. Now put the value. W2 is 5 and urea molar mass, it is given already in your question, you can see it is given 60.05. so put 60.05, you can also take 60. W1 is 95 multiplied by water molar mass is 18 plus 5 by 60.05. so by that way you can easily get the P. Question number 6 is NCERT based index solution question. It is already question number 6. Write down, follow NCERT. NCERT index question. Question number 6, you will write down NCERT index question. Question number 7. Just I will erase this part. You will write down again. But it's very much easier for me to remove this part. Now question number 7. Again you will write down the same question. Now P0. Question number 7, they want to know calculate the relative molecular mass of the solid. That means M2 you need to calculate. P0 they have said vapor pressure of the solution becomes 740. So what will be the vapor pressure of the pure solvent? 760. So P0 is 760, P is 740 divided by P0 is 760. That is W2. What is the weight of the solute given? 20 gram. And what is the molar mass? You need to calculate M2 divided by W1. It is given 180 gram of water. So 180 by water means 18 plus 20 by M. You can easily calculate it. Here calculation is easier for you to do it here. Okay. Here calculation is very easy. So I can do it. You can also do it here. Acha. So that should be 20 by 760. Yes or no? Please tell me. Now this is 20 by M2 by 180 by 18 plus 20 by M2. Yes or no? Please tell me. Now I will reverse it. I will inverse it so that it will become 760 by 20. And this part will come, denominator will be numerator, numerator will be denominator. So this is 10. So 10 bar 20 by M2 divided by 20 by M2. Now that is 38. It is, if you just simply calculate 10 by 20 M2 plus 1. So 38 minus 1, that is 37. That is 10 M2 by 20. Now M2 should be 37 into 20 by 10. What is the value? 74 gram per mole. You can see easily calculation gram. Okay? 74 gram per mole. Question number 8 is also NCERT, but we will do it. Question number 8. done. In your question number 8 it is written just study the question. Calculate the mass of non-volatile solute. Mass is given, which should be dissolved in 114 gram of octane to reduce the vapor pressure 80%. Reduce to 80%. That means the formula you know that P0 minus P by P0, that is W2 by M2 divided by W1 by M1 plus W2 by M2. Now it is said the vapor pressure of the vapor pressure of the solution becomes 80%, reduced to 80%. Then you can write down P equals to P0 into 80 by 100. So that is 4 by 5 P0. If you put this P value over here, if you put this P value, please concentrate. If you put this P value over here, so that is P0 minus 4 by 5 P0 by P0, W2. What is W2? W2 value is basically written the weight of the solute. You need to calculate the weight of the solute. Okay. So that is W2. So this is 4 by 5. W2 by M2. Molar mass given 40. Divided by W1. W1 is 114 gram and octane given. Octane is an example of alkane. And alkane formula you know that CmH2n plus 2. So octane means N value is 8, so that should be Ca8, H18. So that means 8 into 12 and 18 into 1. That means it will be 114 again. So 114 by 114 plus W2 by 40 again. So this value is coming out to be 1 minus 4 by 5 means 1 by 5. So P0 cancel each other. So that is 1 by 5. W2 by 40 divided by 1 plus W2 by 40. Now from that you can simply see, if you reverse it, that is 5 equals to, reverse means I am doing the reciprocal thing. Numerator becomes denominator, denominator becomes numerator. So that is 1 plus W2 by 40 divided by W2 by 40. Now if you simplify it, that will become 40 by W2 plus 1, that is 5. So 1 and 5, that is 4, equals to 40 by W2. So W2 becomes 10. Very important. Always remember here, no need to do the approximation, because in the calculation generally we think that N1 plus N2, that means N1 is more greater than N2, so we will take W1 by M1 in the denominator. But you need to take both solute and solvent here. That means N1 plus N2 you need to calculate. Okay? Question number 11 and question number 7 are same. Question number 12. Question number 12. Why is the vapor pressure lowered when urea is dissolved in water? Why vapor pressure is lowered when urea is dissolved in water? When urea is dissolved in water, there is a lowering of vapor pressure. Lowering of vapor pressure means ki colligative property increases, so that there is a lowering of vapor pressure. That means number of solute increases. So urea, when urea is dissolved in water, that means you indirectly saying the colligative property increases. That means number of solute increases. So urea and water, two solutes are there. So when the number of solute increases, colligative property also increases. Next, why the vapor pressure of the solution of glucose in water is lower than that of the water? So very important. Why is vapor pressure of the solution of glucose is lower than the water? So glucose in water, that means again colligative property increases. Colligative property increases means there is a lowering of vapor pressure. Next, make heading elevation of boiling point. Elevation of boiling point. Do the question number 2 and 3 first. Elevation of boiling point. It is done, I think. Question number. Make a heading elevation of boiling point. Elevation of boiling point, question number 2. So what is the formula? First of all, you need to write down delta TB, that is TB minus TB naught. Elevation of boiling point means solution has greater boiling point than the solvent. That is Kb into M, and M value you all know that is 1000 W2 by M2 W1. Now Kb value, acha, they want to know at what temperature will the water boil. That means TB you need to calculate. TB0 so you already know. So first of all you calculate delta TB. So Kb value is given 0.52, 1000 into W2. W2 is basically given 18 gram of glucose divided by M2, that is the molar mass of glucose. Molar mass of glucose is, you all know that, you have already calculated, 180 multiplied by W1. W1 is given 1 kg, but you need to calculate in terms of gram. 1000. So 1000 cancels, 18 cancel 10. So this value is coming out to be kato? 0.052, yes or no? Now delta TB means ki TB minus TB0. Now TB you can easily calculate, that is 0.052 plus TB0. Now what is TB0? That is the boiling point of water, you all know that, 373.15. So 0.052 plus 373.15 Kelvin. Now what is the value? That is 373. That is coming out to be 25501. 373.202 Kelvin. Any doubt? Question number 3. 1.5 gram of the same, but they are now in that question they are asking about the molar mass of the solute. The same thing you will write down delta TB equals to Kb into M, that is 1000 W2 by M2 W1. Now Kb value it is written 2.52 for benzene, 1000. Also temperature changes also given, 353.93 to 353.23. So you write down 353.93 minus 353.23. So W2 means 1.5 gram they have given. M2 is the molar mass they want to know. And W1 is the weight of the solvent, that is 90. So this value is 0.7, that is, and you can simply calculate it, 1.5, that is 60. So if you calculate, this value is 0.42. Now 0.42 into 100 means ki 42 divided by M2. So M2 is 42 by 0.7. That means 420 by 7. That means 60 gram per mole. Okay? 60 gram per mole. Same type of problem, question number 4. Question number 4 you will do it by yourself. Same problem. The question number 5. Question number 4 I can just simply write down. Question number 4 also they are asking about the molar mass of solute. So here they have said boiling point of benzene 353.23, after that this is 354.1. So you will write down 354.11 minus 353.23. Question number 3 I am saying. So Kb it is written 2.53 into 1000 into W2. What is the W2 given? That is 1.8 divided by M2 you need to calculate, and W1 that is again given 90. You will do it by yourself and you get the answer. M2 means again you are thinking about benzene. So remember, boiling benzene you are thinking, so benzene, no, solute they have not said, non-volatile, benzene is a solvent, non-volatile solute, so calculate M2 in your home. Okay. Question number 5, a solution of glucose in water has boiling point, calculate the freezing point. So from the boiling point concept they are asking the freezing point. Okay. Kf Kv given, it is very important, question number 5 is very important. And it is question number 4 I have done. So question number 5. Question number 5 they are saying a solution of glucose in water has a boiling point 100.20 degrees Celsius. That means delta Tb equals to Kb into M, you all know that. So they have said delta Tb means ki Tb minus Tb0, that is Kb into M. Now it is given the boiling point of the solution is 100.20. 100.20 minus Tb0 100 you will take. So Kb value it is given. Kb value given 0.512. So you can easily calculate M here. So 0.20 divided by 0.512 you will get the M. So you will get the M. After getting the M, you can apply the formula delta Tf equals to Kf into M. Now Kf it is written 1.86 and M is given 0.20 by 0.512, yes or no? So from that equation of molality, from that equation elevation of boiling point you are getting molality. You are putting this molality value over here in the depression of freezing point, you will get the delta Tf. Now after getting the delta Tf, they are asking about the freezing point of the solution. That means here in this case, that is Tf0 minus Tf is will be the value. So if you get this value, Tf0 you need to calculate. So this Tf0 value should be, they have given the solution. Solution you need to calculate. So Tf should be Tf0 minus 1.86 into 0.20 by 0.512. So Tf0 you all know that is 273.15. Minus the calculation you will do, accordingly you will have the value. All the calculation you need to solve, you will get the Tf. Vapor pressure versus temperature plot, we have already done it. The next question number 7. Will the elevation of boiling point be same if 0.1 mole sodium chloride and 0.1 mole sugar is dissolved in 1 liter of solution? What will be the answer? Sodium chloride to electrolyte, glucose to non-electrolyte. So in case of sodium chloride, we will see there is a elevation of boiling point, but in case of sugar there is no such kind of things. So write down. The elevation of boiling point will not be the same. The elevation of boiling point, question number 7, the elevation of boiling point will not be the same. The elevation of boiling point will not be the same if 0.1 mole of NaCl, or 0.1 mole of sugar is dissolved in 1 liter of water. Full stop. NaCl is an electrolyte. And will dissociate into Na plus and Cl minus. Full stop. So number of solute, also number of ions increases. Leading to elevation of boiling point. But in case of glucose, which is a non-electrolyte, elevation of boiling point will not be observed. Is it clear? Question number 8. Same problem. Explain why on addition of 1 mole of glucose to 1 liter of boiling point of water increases. So basically you need to know कि glucose is non-volatile and non-electrolyte as well as undissociated. So there is no such kind of thing you will observe. Same answer you will write down. Depression of freezing point, make a point. Depression of freezing point, it is very important. Question number 1. Why does sodium chloride solution freeze at lower temperature than water? Same area, same answer. Same answer you will write down. In case of elevation of boiling point, whatever you have written, depression of freezing point, you will write down the same thing. So NaCl is an electrolyte, so it will dissociate into ions. More number of ions, that means we will write down. More number of ions means we will write down. Colligative property increases, that means freezing point decreases. But in case of glucose, non-electrolyte. Question number 2, draw a graph, it is already done. Question number 3, depression of freezing point water observed for the same amount of acetic acid, trichloroacetic acid and trifluoroacetic acid increases in the order given above. That means depression of freezing point of water observed for the same amount of depression of freezing point observed at the same amount of acetic acid, trichloroacetic acid and trifluoroacetic acid increases in the order given above. What is the reason? It is very important question. Question number, I am talking about question number 3. That is depression of freezing point. Depression of freezing point. Tell me. Acetic acid formula is CH3COOH. Trichloroacetic acid is CCl3COOH. And trifluoroacetic acid is CF3COOH. This is the increasing order written of what? Depression of freezing point. Increases in the order given above. What is the reason why the depression of freezing point you will see increases like this order? Always remember, it depends on the acidity. Because acetic acid, trichloroacetic acid and trifluoroacetic acid, the acidity of all these 3 acids are different. The acidity order it is written like this. Why? This trifluoroacetic acid is more acidic, which we have already discussed in class 11, some basic organic chemistry. I have said with the increase of electronegative element, acidity increases. So here fluorine, here chlorine, here hydrogen is there. So fluorine is more electronegative, so acidity is more. Then chlorine, then acetic acid. Yes or no? Now when there is a fluorine present, acidity is higher. Acidity higher means it can easily dissociate to give you H plus. Just try to understand. And that means trifluoroacetic acid will give H plus more faster than the other, because it is more acidic than the other. So it is more acidic, it will give H plus in more extent rather than in the other acids. Just try to understand. So it will dissociate more. So it will dissociate more means number of solute will be more for trifluoroacetic acid. When number of moles increases, that means colligative property increases. Number of moles of solute increases means colligative property increases means freezing point decreases more. Because of that reason, depression of freezing point will be more. So it will follow this order. So write down. With the increase of electronegativity, or EWG, EWG means electron withdrawing group. EWG you have done it, EWG, EDG. So EWG means electron withdrawing group. So with the increase of electronegativity or EWG, acidity increases. EWG means you can write down electron withdrawing group, otherwise you will forget. Acidity increases. With the increase of acidity, degree of dissociation with increase of acidity, degree of dissociation into ions also increases, isn't it? Degree of dissociation into ions increases, leading to increase in colligative property, leading to increase in colligative property, leading to increase in colligative property, leading to increase in colligative property. Thus the depression of freezing point of water increases, the depression of freezing point of water increases in the order next line write down, acetic acid comma trichloroacetic acid comma trifluoroacetic acid. Question number 4-5 will do. Question number 4-5. Let's see what is question number 4-5. Hey. Question number 4 and 5. Question number 4, they are saying 5% solution of cane sugar in water has freezing point 271 Kelvin. Calculate the freezing point of 5% glucose in water if the freezing point of pure water is 273.15. So the same equation we will write down, but here delta TF. Kf into m, that means 1000 W2 by key n to W1. Yes or no? Right. So delta TF means key TF0 minus TF, that is Kf value given already. Kf value, what is the Kf value given? Kf value, Kf value is not given, but I have said you need to remember the Kf value, and it is given water. So what is the Kf value for water? 1.86. You all know that. 1000 W2, that W2 is weight of the solute. 5, again the same concept, 5% solution of cane sugar, 5% solution, aqueous solution of cane sugar. That means cane sugar is 5 gram. Cane sugar is 5 gram. Solution should be 100 gram. So water should be how much? 100 minus 5, that means 95 gram. The same concept. So cane sugar means that you can take it W2 and water you can take it W1. So W2 is 5 divided by M2. M2 is the molar mass of the cane sugar, that is given. Sugar means you all know that C12H22O11. If you calculate it, this value will be 342. Remember. So that is 342, and W1 is 95. So from there you will get the value. But here they want to know the freezing point of the solution, that means TF they want to know. So TF should be TF0 minus this value 1.86 into 1000 into 5 divided by 342 into 95. Calculate. TF0 you can write down 273.15 Kelvin minus 1.86 into 1000 into 5 by 342 into 92. You need to solve it by yourself, but don't use calculator. After doing it, you can solve it by the calculator and see what is the change of values you are getting in the calculator, and you are doing it by yourself. So you need to do it by yourself. Okay. Question number 5. That is the last problem of today's class. Question number 5. 45 gram of ethylene glycol is mixed with 600 gram of water. Freezing point of the depression of freezing point you need to calculate. Depression means the delta value, and the freezing point of the solution you need to calculate. So 45 gram of ethylene glycol is mixed with, same problem, nothing else. Delta T is equals to Kf into M. Now I will write down directly. Kf value is again water. See, the value is not given. And you see your CBSE board question, whatever we are doing. 1.86 multiplied by 1000 into W2. W2 is the weight of the solute, 45 gram, divided by M2. What is the M2 value? M2 value they have said C2H6O2. So they have said the solute is C2H6O2. That means 2 into 12, 24, 6, 32. So 30 plus 32 is 62. Multiplied by M2, you will write down. M2 is basically 62. You need to calculate it like this manner. 62 gram per mole, so 62. And W1 is 600. Okay. So delta TF you can easily get by that method. Now delta TF, that is depression of freezing point, that is 5A depression of freezing point, and B they are saying the freezing point of the solution. Again the freezing point of the solution should be 273.15 because it is water, minus 1.86 into 1000 into 45 divided by 62 into 600. So that will give you the TF, that means the freezing point of the solution. Okay. So by that way you can easily calculate it. In the very next class, there are some parts remain in terms of freezing point. Two problems I will be solving, an osmotic pressure and abnormal colligative property. And after that we will start electrochemistry. Okay. So that's it. Just study these questions. Again, the very next week also from the 5:15 we will have the exam, and after that we will have the class. And only solutions chapter. Remember, only solutions chapter. So that's it.